good. Thank you very much. So, all right. Before I get into the presentation, I did want to talk about my job a little bit because people are always interested in a meteorologist or a weather person's job. I am a meteorologist, which is just a scientist who studies the weather. I am part of a organization called the National Weather Service, as Dr. Mike said, and we are part of the U.S. government. There's over 120 weather offices all across the United States. Each weather office kind of focuses in on its own area of responsibility. And like I said, I'm in the El Paso office. Oh, here, let me turn on my laser. Which is, it does say El Paso, but like Dr. Mike said, we're actually located in Santa Teresa, New Mexico. We cover just a little bit of far west Texas and a big hunk of southern New Mexico. Some of you guys may be in northern New Mexico. They're covered by the Albuquerque office. You can see that Albuquerque covers a big hunk of basically the northern 2/3 of New Mexico. And then the Midland, Texas office actually also covers the southeast corner, Eddy and Lee County of New Mexico. So there's 3 National Weather Service offices that cover New Mexico. So we've got all of New Mexico covered. And you can see each one of these offices, they kind of focus in on their own area of responsibility. And what they do is they're the subject matter weather expert because weather is different all across the country. And we issue all kinds of warnings and advisories and forecasts. Now, if you've ever been at home at night and you've seen mom or dad, or you've had mom or dad's cell phone, or maybe your cell phone's made that noise, or you see the weather word scroll across the screen on the television, it's the men and women who are working in the El Paso, the Albuquerque, or the Midland office that are issuing the warnings to let you know when the bad weather is coming to town. Whether it's a tornado, whether it's flash flood, or real strong winds, maybe a winter storm, something like that. So we issue all these different kinds of warnings to because it's the mission of the National Weather Service to protect lives and property from the weather. Now, that's part of our job. The other part of our job is to issue weather forecasts. Now, weather forecast is just simply a guess or a prediction of what the weather is going into the future. Now, sometimes that future is 5 minutes from now. Sometimes that future is 7 days from now. It just depends on which forecast we're issuing because we issue all kinds of different weather forecasts. We issue forecasts for pilots, for planes, for people who are flying planes into like the El Paso International Airport or the Albuquerque Sunport. But we also issue forecasts for smaller airports like Tucumcari or Deming or Las Cruces. So we also issue forecasts for boaters. So any of the boaters who are out on the lakes of New Mexico, like Elephant Butte or Caballo. We also issue forecasts for the people who are fighting the forest fires up in the mountains of New Mexico. We also issue forecasts for people like me and you, and that's called the public forecast. And that just lets you know, is it going to be hot? Is it going to be cold? Is it going to be rainy? Is it going to be dry? Is it going to be sunny, cloudy, windy, or calm? So that you can make a wise decision, whether you need to put on a jacket if you're going outside. Maybe you need to take an umbrella if you're going to the grocery store. Maybe you want to see if you can wear shorts if you can go outside and play. Because it's the mission of the National Weather Service to protect lives and property from the weather and to help people make wise weather decisions. And you know what? Weather affects our lives in so many different ways. A lot of people will ask, well, where does the weather come from? And I wish that I could tell you that we had a big machine that we could just push a button and say, oh, I want it to rain today, so I push the rain button. And it just doesn't work that way. All of the weather on the earth starts not on the earth, actually. We have to get off the earth and look towards the sun. The sun is where all of the weather on the earth actually starts. So that big, glowing, hot gas ball up in the sky is where all of our weather starts on the earth. Now, you guys all know that the sun is hot. The sunlight actually shines that heat energy, that sunlight energy passes through the air and then strikes the ground. And then the ground gets warm by that touch. If you've ever gone outside on a summer day, just like we just rolling through, we just finished up summer, you go outside, you can feel that sunlight on your skin, how hot it is. Well, a lot of people think that the sunlight heats up the air, and that's just not the case. The sunlight passes through the air, just like light passes through a window, and then it strikes the ground, and it starts to warm the ground up, and then that ground warms the air up from below. It's just like if you've ever seen mom or dad when they put a pot on the stove and they turn on that burner heats up the pot from below. So the same thing happens on the earth. That sunlight shines through the air, strikes the ground, warms up the ground, and then the ground warms up the air below. Now, some of you guys may have had the benefit, or maybe you guys live in places like Taos or Ruidoso. You know that when you go up in the elevation, it gets colder. And that's because as you go up higher in elevation, you're getting further and further away from the main part of the earth. So as you go up away from the earth, it gets colder. You know, if you've ever been on one of those big planes that flies across the country, you know, it's nice and comfortable inside the cabin of the plane, but just outside that window, it's super duper cold when you're up there at flight level. So as you get away from the earth, it gets colder and colder as you move up higher and higher and higher. So I don't know, Mr. Mike, is there any questions that we need to work on?
At this point, just some comments have been made, not many questions, so I think we can continue on.
Okay, so we're going to talk about 3 kind of unique things about the earth, or kind of interesting things about the earth. Interesting fact number 1 about the earth is, guess what? It's round. We live on this big beach ball that we call the earth, but because it's round, that means that the sunlight doesn't strike the earth evenly. And what I mean by that, you can see the arrows here are kind of like the sun's rays, and they're moving in towards the earth. But you can see, if you imagine, they kind of strike more directly in the middle part of the earth. But if you look up towards the poles, or down towards the poles, towards the North Pole or the South Pole, the top and bottom of the earth, you can see that sunlight kind of strikes at more of an angle. If you've ever taken a flashlight and you hold that flashlight straight over the table, you can say it makes a concentrated circle right there on that table. But if you start to tilt that flashlight, it's the same amount of light, but it's spread out over a wider area and it's dimmer. And the same thing happens on the earth. As you move up towards the top of the earth or the bottom of the earth, the north or the south pole, that sunlight gets spread out over, it comes in at a wider angle, spreads out over a wider area, so it doesn't heat up the ground as effectively. And that's why the poles, the North Pole and the South Pole of the earth, are colder than the middle part of the earth, the equator. Here, let me show you on another graphic here. You know what? I believe that just yesterday we passed what we like to call in the weather business the autumnal equinox. And that means, that's just a fancy way to say, hey, it was the first day of fall. But what happens on the first day of fall is that the sun's rays are coming straight into the middle part of the earth, what we call the equator. It's kind of like the belt around the earth. It's one of those invisible lines on the earth that the map makers put on there. And you can see that the more direct rays of the sun are striking right in the middle of the earth. Now this 90 degrees here that you see, that's not talking about the temperature, not degrees in temperature, but degrees in angle. So like when you're talking about like a protractor or a compass. And that's at 90 degrees, that's that perpendicular angle. So it means that the sun's rays are coming in most directly right here in the middle part of the earth. And then as you head up towards the poles, you can see the angles get lower and lower and lower. And that's that tilting of that flashlight as you move through time. So that, or as you move up towards the north or the south, you get that tilting of that flashlight and that spreading out of the sunlight. And again, the lower the angle, kind of like the lower the temperature. Now, something interesting fact number 2 about the earth is actually tilted. The way the earth leans over on its axis, it's tilted over actually a 23.5 degree angle. It doesn't matter that you guys remember the exact angle, just remember the earth is tilted. And because the earth is tilted, that's what gives us our 4 seasons out of the year. Because whichever part of the earth is kind of leaned towards the sun, that's part of the earth has its summer. Now, I don't want you to think the earth is like going to fall over or anything. It's just the way the earth is made. We're tilted over like that. Like I said, whichever part of the earth is tilted towards the sun, that's their summer. But whichever part of the earth is tilted away from the sun, that's their winter. So we just finished up summer here in New Mexico, and it was a hot one, let me tell you. But you can tell that you see that 90 degree angle. It's no longer striking at the equator. Now it's striking at another one of those invisible lines on the map, the Tropic of Cancer. I don't know why they call it that. They just do. It's one of those invisible lines on the map. So you can see the more direct rays are striking in the northern part of the Earth, and those lower angles are striking in the southern part of the Earth. That's why we're tilted towards the sun. That's why it's our summer. And for the southern hemisphere, for places like South America or Australia, it's their winter. But guess what? 6 months later, the opposite happens. Now, the northern part of the Earth, the northern hemisphere where we live, is tilted away from the sun, and the southern part of the Earth, the southern hemisphere, is tilted towards the sun. And that's when it's winter for us, but it's summer down there in South America and Australia. So when you guys, because we're just getting ready to go into winter here in a few months, as you guys are in the middle of winter and you're trying to think about what jacket to put on, which hat to put on, how many layers of clothes do you need to wear so you can stay warm when you go outside, the kids in Australia at the exact same time are trying to figure out which swimsuit to wear, what sunscreen to put on, and which beach to go to, because it's summer down there. So when it's winter in the northern hemisphere, it's actually summer in the southern hemisphere. Now, I don't want you to think that the Earth is kind of wobbling around on its axis. Yeah.
We got a few questions based on that slide, so I want to interrupt you and have you answer some questions. First of all, we got a question from Luke. What is the Tropic of Cancer and Capricorn? Can we be a little more specific? Maybe what you said?
It's actually where the Tropic of Cancer and the Tropic of Capricorn are just invisible lines on the map, and it's where the Earth's the most direct sunlight rays come in on that the longest day and the shortest day of the year. So the first day of winter and the first day of spring. So it's just an invisible line where that 90-degree angle happens to strike there on the Earth. Why they call them those, the Tropic of Capricorn and the Tropic of Cancer, I don't know off the top of my head. If I had to do, it's probably something to do with the celestial, the stars, and where they are in the zenith above us. But it's just a name that they've given, and it just means that that's the furthest south the most direct rays reach during the winter. And then if I back up one more, and this is the Tropic of Cancer is the most furthest north that the most direct rays strike the northern part of the Earth. But the key thing to remember here is that during our summer, we're leaned towards the sun. So the direct rays are striking the northern hemisphere, and during our winter, we're tilted away from the sun here in the northern hemisphere, and the opposite side of the southern part of the Earth is kind of pointed towards the sun.
Okay, so I'll make a comment there. There's a couple more questions, by the way. The Tropic of Capricorn and Tropic of Cancer, I think, are named after the constellations Cancer and Capricorn. And you can find those online if you look for them. Right. And it has to do where the sun is at in the sky. I learned this in astronomy. Now, for the other question is, how big is the Earth? Do you happen to know, Tim?
It's big.
Okay, I can actually give a number to that in kilometers.
I don't know off the top of my head.
I think it's around 6,000 kilometers in diameter, if I remember right. And so that's something I teach in class. That's why I know that one. And
so one of the interesting things to remember, because I described the Earth as a beach ball. The Earth is not exactly a nice round marble or circle. It's actually kind of a squished ball. And I think a beach ball, if you've ever looked at a beach ball, it's never perfectly round. It's kind of squished a little bit in one direction or the other. So that Earth being described as a beach ball is actually a very good way to describe it. So it's actually, a little rounder in the middle. If you measured it around the equator, it's a different distance than if you measured it pole to pole, something like that, because it's not a perfect circle around.
Okay, so, and one more question. What would happen if the Earth wasn't tilted?
I think, that's a great question, and I'm going to just try to talk off the top of my head here. I imagine as long as we're still rotating around, we'd have a lot of weather like we're having right now, where it would get very hot near the equator and cold at the poles. I think that one of the advantages that we have with the 4 seasons, with it being tilted, is that it gives us a way to kind of move the cold air away from the poles and the hot air away from the equator. And that's actually what a lot of the weather systems are doing, are just simply trying to balance out that difference in that sunlight. If we were always like spring or fall, I think, you know, it on the one hand, it sounds like it might not be a bad thing, but my guess is the equator would continually get hot, 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 and the poles would get colder and colder and colder. And I think we would get into an imbalance that would cause some pretty extreme weather across the area.
I would agree with that. As a physicist, I would say the same thing. Also, there was an interesting comment that Kayla doesn't want to be warm; she wants to be cold.
Well,
And
I think
so I
she's about
agree
to
with
get
you,
her
Kayla. I
wish.
totally agree with you. Okay, so
I
okay,
know.
you can go ahead on with the slides.
Sure. It's been a long, hot summer, and we've got a little bit more. I know we've got more heat coming. So unfortunately, we still got at least a couple more weeks, but I promise winter will eventually come. Because as you guys can see here on the map, you know, I don't want you to think that the Earth, you know, how we talked, it was tilted. It doesn't wobble around on its axis. It's actually tilted over in the same direction all the time. But as we make a circle around the sun, or what we call the orbit around the sun, different parts of the Earth are pointed towards or away from the sun. So we're right here at fall. We're one day into fall, officially, astronomically speaking, and we're getting ready to head into winter. And you can see here on winter is when the northern part of the Earth is pointed away from the Earth, and the southern part of the Earth is pointed towards the sun. And then 6 months later, as we continue to orbit around the sun, you can still see now the northern part of the Earth is pointed towards the sun, and the southern part of the Earth is pointed away from the sun. So when it's summer in the northern hemisphere where we live, it's actually winter down there in Australia for those kangaroos and those koala bears. All right. So we talked
So we
about
got
how.
some more questions,
Sure, go
actually.
ahead.
You want to field them? Okay. So why is the equator right in the middle?
It's because if you hear inside the word equator, if you hear the word equal is hiding in there, and it's basically equal distance from the North and the South Pole. It's just the middle part of the Earth. I like to tell people it's like the belt of the Earth. It's right around the middle.
And Stevie, if you have a question, go ahead and type it in the chat room. That's easier. Please do that for us. And then Christian actually looked it up. The Earth is about 25,000 miles, and I assume that's in diameter.
Yes.
So that's in miles. I think my answer was right in terms of kilometers. How did the Earth get made? That's a good question, and you might have some ideas on that.
I like to think that God kind of put it all together and kind of got things going. There's also theories that how planets form when these solar systems are formed and things like that. You know, cosmology is kind of an interesting science, and if you guys, there's all kinds of different sciences, and I encourage you guys, if you're interested in weather or volcanoes, you know, planets and moons and things. There's all kinds of science that you can do research on and that you can study and become those kind of scientists.
And then let's see, what else do we have? Does the Earth spin fast or slow?
I think it spins pretty fast. I forget it's going along at over 1,000 miles an hour, and I'm pretty sure that's right. I think, Dr. Mike, maybe you can Google that answer while I'm talking.
No, I think you're pretty close to that, and that's at the equator, of course, because at the pole it's not rotating at all. And the fact that it spins fast or slow, just know that it turns once on its axis every, ready for this, 1 day. So every day it turns around once.
Right.
And that doesn't seem fast unless you're traveling at 24,000 miles in diameter in 1 day. That would be pretty fast.
Right.
And then how big is the Earth and the sun? If you compared the Earth to the sun, how would they relate? Do you know, Tim?
I believe you can put several hundred Earths inside the sun. So if you take the Earth and put it up against the sun, it looks like a teeny tiny little dot. A lot of Earths can fit into the sun. If you took the sun and it was just this sphere and you put in the marble the size of the Earth, you could put a whole bunch of those Earth-sized marbles inside the sun.
The size of the sun, by the way, he said it's several hundred times bigger than the Earth. Why are there seasons? And I think that's what Tim was trying to explain here. It's the tilt of the Earth that actually causes that.
Exactly.
How long till the sun explodes?
A long time. You don't have to worry about it.
If we don't have the sun, do you know how cold it would be? And I can actually answer that question, but can you?
Well, yeah. So it would be actually, I believe it'd be minus 73 degrees. It'd be absolute zero. Without the sun, we're close to what's called absolute freezing. Or absolute zero, and that's where there's just no heat energy at all. The molecules do not vibrate or move, and it's super duper cold. So we're thankful for that we do have the sun. We would be without the sun, we wouldn't exist. So it's great that we do have it to keep us warm. Of course, it gets a little too hot sometimes, it seems like.
Okay, and then does the sun spin?
Yes. It certainly does. And actually, one of the neat things is that in New Mexico, we have a world-class solar observatory up in the Sacramento Mountains, there by Cloudcroft and Ruidoso. So they do a lot of sun research in New Mexico.
And then Caden had a question. What would happen if half the Earth fell off?
It would be probably a bad thing, I think.
I think so, too. It would definitely throw this whole weather system into a completely different pattern.
Exactly.
And I'm looking to see if there's any more questions that I'm missing here. Will the Earth last forever? And the answer, I can answer that, Ava, it will not. It will eventually get swallowed by the sun, if nothing else, because the sun will turn into what's called a red giant eventually, and it will actually become part of the sun. But that's many, 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 many years from now. You don't have to worry about that.
Nope.
How much water does the Earth get in a decade?
Rain-wise?
Yeah.
Well, okay, so we're going to talk about that here later. So hold on to that question, and we'll talk about that later. But why don't I go ahead and kind of go on with the presentation here? And
yeah, I'll see if I can answer some of the remaining questions on the chat. Let me see.
So I wish we had all these questions in our Ask a Meteorologist session.
Yeah.
All right. So we already covered interesting fact number 1 about the Earth, that the Earth is round. And we covered interesting fact number 2 about the Earth is that it's tilted over on its axis. Interesting fact number 3 about the Earth is that it's mostly covered with water. Now, most of us here live in New Mexico. We live pretty far away from the oceans. But believe it or not, almost 3/4 of the Earth is covered with water. And land and water heat up differently. You guys may have experienced this. If you've ever gone to like the pool or one of the lakes, you know, as you're walking around next to the lake or on the concrete next to the pool, you know that concrete can get super duper hot on your feet, maybe so hot that you got to jump into the pool or jump into the lake to cool off your feet. And you go, that feels much cooler. But if you think about it, the same sunlight shines on the concrete or the sand as shines on the water, but they're very different temperatures. And that leads to some interesting things because the land heats up very quickly and water takes a long time to heat up. But so what happens is that the land will heat up very quickly, but that water stays cool. And you guys may have experienced this if you've ever had, you said you wanted like spaghetti or macaroni and cheese. Mom or dad said, well, we're going to have to boil some water. So they put the water on the stove in a pot, turn the heater on, turn the burner on, and you go, is it ready yet? No. A couple minutes later, is it ready yet? No. Well, how about now? No, not yet. Water can absorb a lot of heat before it starts to raise its temperatures. So that water heats up very slowly. But interesting, once the water does heat up, it's like a big heat battery. It holds on to that heat and actually loses that heat very slowly. Whereas the land, it heats up fast, but guess what? You know, at night here in New Mexico, you may have experienced this. It may be warm during the day, but at night you're like, hey, it is cold because that land cools down very quickly. Matter of fact, it cools down faster than the water. Once that water, like I said, stores up that heat, it actually holds on to it. And it's not uncommon at all during the winter around like the Great Lakes of the United States or on the East Coast that at night the land is actually colder than some of the water surrounding it. All right, this uneven heating actually leads to what we call uneven pressure distribution. Now, you guys may have seen a weather map on the internet or on the television, and it's got these H's and L's on it. The H's stand for high pressure, and the L's stand for low pressure. All that means is that where you have the H's, you have a little extra air molecules, and where you have the L's, you have a little less air molecules. So you got these H's and these L's. And what happens is that these H's and L's, and we're going to talk a whole bunch about these high and low pressure here in the next section, but this is really what gives us a lot of our weather. Now, these areas of low pressure, if you look at them, they all have kind of formed up over the big land masses. And that's because, remember, that differential heating. What that means is that sunlight, remember, it shines through the air, heats up the ground, and then the ground heats up the air from below. But once you start to heat up that air from below, it starts to rise, just like a hot air balloon. If you guys have ever seen a hot air balloon and the pilot turns on that burner, that balloon starts to float up. Well, the same thing happens on the Earth. When that ground starts to warm up and heats up the air from below, the air right near the surface of the Earth starts to lift up away from the Earth. And that's why you end up with a few less air molecules near the surface of the Earth. That's why you get these areas of low pressure. Versus out over the oceans, remember the water takes a lot longer to warm up. So relatively speaking, it's cooler over those oceans, so they don't have that warm air to rise away. So they have higher pressure over these oceans, and that's why over the oceans you tend to get these areas of high pressure formed versus over the lands. Now, what's interesting thing for our weather is that these areas of high and low pressure don't stay put. They don't stay anchored where they form. Did you guys know that the air that's above us is always flowing along like a river? It's always flowing along like a river. If you've ever gone out on a summer day and you've seen those big white puffy clouds, if you stand there long enough, you can actually see them floating along. And they're floating along in this river. Well, this river is moving those clouds along, but it's also moving these areas of high and low pressure along. So this area of low pressure over the desert Southwest where we are might drift off to the East Coast, and this area of high pressure over the Pacific Ocean might drift into the West Coast, because where we live, the weather in general moves from the west to the east, or from the West Coast to the East Coast, or from California over to New York. So in general, our weather is always moving from the west to the east. Now, this areas of high and low pressure, one of the things that the Earth doesn't like is these differences in pressure. So what we do is, since we have extra air molecules at high pressure and we have less air molecules at low pressure, we tend to want to try to move some of these air molecules from the high pressure to the low pressure. It's the same thing like if you had a bunch of extra Legos and your friend didn't have hardly any, you would give some of your Legos. You kind of shove all those Legos over towards your friend, right? So when those air molecules are moving from that high to that low pressure, guess what? That's what gives us our winds. So when we get our winds is when you're moving those air molecules from the high pressure to the low pressure. So if you've ever gone outside on a really windy day, rest assured, on one side of you was high pressure, and on the other side of you is low pressure. All right. You guys asked some good questions, and Dr. Mike and I, but guess what? Now it's time for me to ask you guys some questions. So there's a couple of ways we can do this. I don't want everyone to unmute your mics and yell out the answer. Instead of that, that would be crazy. Instead type in your answers to the chat, or just hold up a finger, because it's going to be 1, 2, 3, or 4 is the question. So, all right, here's your first question. Because of the Earth's tilt on its axis, we get what? Is it 1, day and night, 2, gravity, 3, winter, spring, summer, or fall, or 4, the lunar cycle? What do you guys think? I see a lot of 3s. I see people holding up 3s. Awesome. You guys did great. I'm so glad that you paid attention. So the correct answer is 3. Remember, because of that Earth's tilt on its axis, we get those 4 seasons, that winter, spring, summer, or fall. All right, one more question for you. When it's summer in the northern hemisphere where we live, what summer is it in the southern hemisphere? Is it 1, summer, 2, winter, 3, fall, or 4, spring? What do you guys think? I see 2s. I see some 3s. I see a 4. So when it's summer in the northern hemisphere where we live, it's actually winter in the southern hemisphere. Remember, from the north to the southern hemisphere, we have those different, we're the exact opposite. So when it's summer for us in the northern hemisphere, it's actually winter for those kangaroos and those koala bears down there in Australia. You guys did great, 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 great. All right, we're gonna jump into areas of high pressure
So
and
Tim, before you
pressure.
go on,
Yes, please go ahead.
I've been watching a lot of questions come by, a lot of which have been answered by the students themselves. So I like
Very
to
good.
see that, by the way. So if somebody is a little bit upset with that, the teacher or something, don't be upset. I like to see students answer each other's questions, and I'll try and correct any that are wrong. One question came up about the monsoon season. Can you give us
Yes.
an idea of where that comes from?
So the monsoon season is, by definition, a seasonal shift in the wind. What happens is that we get a big area, talking about these areas of high and low pressure. During the summer, we get what's called that heat low. Remember, that heat really warms up the ground, and it tends to lift up that air, and we end up with an area of low pressure. We're right over the desert Southwest. We get what's called a heat low. And whether it's centered in Arizona, New Mexico, it tends to kind of wander around. But as you can see on my graphic here, when you get one of these areas of low pressure, it tends to draw the air into it. So when we get really hot during the summer, it tends to pull the air into us from different directions. Now, we are far away from the oceans, but when that monsoon flow sets up, the seasonal shift in the winds sets up, it will draw in moisture from the Gulf of Mexico. It will draw in moisture from the Pacific Ocean off the coast, the west coast of Mexico. And it pulls that moisture up into the desert Southwest. And that increased moisture is what helps fuel our monsoon thunderstorms. Unfortunately, this year, if you guys were watching, instead of a big area of low pressure forming, we had a big area of high pressure sitting on top of us. And it was just, that's sometimes what happens with the weather pattern. We end up with these areas of high pressure, low pressure, and it really kept the monsoon moisture was not able to get in here very effectively. We did have some days that had rain, but really it was a very disappointing kind of monsoon season. And I know we still got about another week to go, but guess what? I've already looked at the forecast. Not many of us are going to get rain in the next week or so. So it was very disappointing monsoon season. Unfortunately, we didn't get that low that we like to see get set up like we hoped it would. But that's what it is. It's just a seasonal shift in the wind, and when that wind shifts, it'll pull in that moisture from the Gulf of Mexico and the Pacific Ocean.
Okay, so let me make a few comments to the students who are listening in. Please do not keep typing twos, Isaac. Okay, and also the rest of you, I'm watching for questions. There's a lot of questions, I understand. Later on, we'll actually go through. I'll save the chat if I can, and we'll go through that chat and try and get back to you guys the answers to some of the questions that we're not answering here. But I think there was one about tornadoes, and it asked how much pressure is in a tornado, which I think is a great question. So I'm going to pick out the best questions. I'm going to ask them for Tim Bryce here.
You bet. And we do have a section. We are going to talk about tornadoes real briefly here in just a few minutes. But first, we got to get to understand the concept of high and low pressure. So, we've already talked a little bit about high and low pressure. With these areas of high pressure as they set up, like I said, the air is moving away from. We're trying to take some of those air molecules away from the high pressure and move them towards the low pressure. So the air molecules are moving away from the high pressure. And what that does is that tends to create this area of this empty space above the high pressure. So the air above it tends to drop down or sink down from above. And the reason you get that is because you got that sinking motion. And when you get that sinking motion, that's the exact opposite of what you want if you want clouds or anything. So that's why with this high pressure, we've got this bright sun. You got that sinking motion because all the air is running away and it's trying to fill in that empty space. But this area, the exact opposite is happening with the area of low pressure. The low pressure, all that air is being drawn into it because it has less air molecules there. So all that air is being drawn in. And this low pressure is drawing in that air. Now, when that air starts to get together, it gets squished, it gets confined. And just like when you squeeze a tube of toothpaste, that toothpaste has two choices. It can either go out the back of the tube or it can go out the opening of the tube. But you know what? When they make that tube of toothpaste, they really seal the back of that tube really well. So the only choice for that toothpaste is to go out the opening and go on your toothbrush and then you brush your teeth. Well, the same thing happens on these with this area of low pressure. All that air is rushing into that area of low pressure and it gets squeezed, and it has two choices. It can either go down into the ground or go up. Well, it can't go down into the ground because that ground's hard. It can't like burrow into the ground. So what it does is it gets squeezed and then it pops up and that air goes up. And now anytime you get air moving up in the atmosphere, that's when we can get our most interesting kinds of weather, because that's what gives us clouds and rain and thunderstorms. So a little more detail on these areas of high and low pressure. I tell people, if you want to remember in general the kind of weather you expect with high pressure, it's the H, because the H stands for high pressure, but it also can say it stands for happy weather, because so many times that's what we get with high pressure, is what people might call high pressure or happy weather. We get clear skies, calm conditions, dry weather, there's no clouds. It can get warm during the day like we saw, but at night it actually can get cool, because the blankets during the day can actually cool us down or keep us warm. They act like the clouds act like a blanket to keep us warm. And if there are no clouds, then remember how that ground can quickly radiate its heat. The ground radiates that heat, so it can actually feel cool, especially in the desert like we've seen. Now, the opposite happens with low pressure. Again, the L is the key for the low pressure, because I say the L stands for low, for the low pressure, but it can also stand for lousy weather, because so many times the weather that we get with low pressure is what people might call lousy. You get cloudy skies, you get windy conditions, you get wet weather, and a lot of times it can actually be followed by colder weather. So with this area of low pressure, we get that uplifting motion, and we get all kinds of interesting weather. And unfortunately, a lot of people think it's lousy. I kind of like the low pressure. It gives us some interesting weather. So before we jump into talking about cold fronts and warm fronts, I was wondering, does anybody, Dr. Mike, did anyone have a question for us?
Yeah, we had a couple of good questions. One was, how does the tsunami form?
So a tsunami forms usually with a big earthquake out in the ocean. If you guys have ever been in I'm sure none of you guys have done this before, but if you've ever been in the bathtub and you get to one end of the bathtub, and with your hand you push the water, and you watch that big wave rush down to the other end of the bathtub and make the big splash on the wall, and water goes everywhere, and then mom or dad comes in and says, "Stop making a mess in the bathroom." That's kind of what happens in the ocean. That tsunami, that earthquake, gives the ocean a big push, and that big wave moves off from that earthquake where the earthquake happened. And usually when you're out in the middle of the ocean, you don't notice the tsunami wave. It kind of goes by and it travels very quickly. But what happens when that tsunami wave approaches land, it grows into this giant wave and actually will reach well inland. Up to several miles inland on some locations. And unfortunately, we've seen several devastating tsunamis in the last 20 years. There was one in Japan right after a big earthquake there. And then back in the I think the early 2000s, there was a big tsunami in Indonesia after a big earthquake there. And unfortunately, tsunamis usually do kill many people, because the water just reaches so far inland, people are not used to. So when there's a big earthquake, if you're near the coast, many times they tell people to immediately go to higher ground, because there could be a tsunami wave coming, and it's very difficult to get the word out quickly, because usually only have minutes to maybe an hour to get people out of harm's way when these big tsunamis happen.
Okay, so I'll just let you know, Tim, we're in the last 10 minutes, but
okay.
I think there's been enough questions about this one. I really want to ask it. A lot of the students are very interested in how tornadoes form.
Mm-hmm.
And I will point out to the person that asked, a waterspout is a tornado that's on water. And if you have questions, please do type them in the chat room. I'm watching those. We're not going to turn on microphones because that'll take too long. So please put it in the chat room and I'll watch for your question there. And so go ahead and talk a little bit about tornadoes and I'll watch for other questions here.
So you know what? I apologize. I'm going to jump through a bunch of slides here, because guess what? I got a slide for that. So We're going to
Yeah, let's do
jump
that.
through, blah, 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 water cycle. Okay, so tornadoes. Here we go. So tornadoes actually have the strongest winds on the earth. Tornadoes do occur in every state of the United States. So it's kind of hard to tell, but there's little lines on here. I got a better map here in just a second. But you see a number in each state. The number in each state represents the number of tornadoes that state sees each year. So you can see Texas, they got almost 150 tornadoes. But look at this, New Mexico. On average, New Mexico gets almost 10 tornadoes each year. And even places like California and Washington and Oregon, where you don't think they do get tornadoes, they do get a few tornadoes each year. But by far, the vast majority of the tornadoes occur in the middle part of the country, what we would call Tornado Alley. And that runs up from North Texas, Oklahoma, Kansas, and Nebraska. And the reason it's called Tornado Alley is because all the weather ingredients come together just right there in the middle part of the country. When you're making a thunderstorm, you need to have the certain weather ingredients. You know, when you're trying to make a tornado, it's kind of like when you're trying to make a cake. You have to mix together all the right ingredients in all the right amount. If you put in too much of one ingredient, like if you put in a bunch of flour, it's not going to be a nice cake. Or if you leave out an ingredient, if you leave your eggs out of your batter, it's not going to be a nice fluffy cake. The same thing happens when we're trying to make a tornado. All the weather ingredients have to come together just right to make that tornado. And some of those weather ingredients include warm, moist air coming out of the Gulf of Mexico, cold, dry air on the backside of this system, actually warm, dry air at a middle layer of the atmosphere. All of these need to come together to work, and then we get what's called the jet stream. You know, that river of air I talked about? That sometimes parts of that river of air are actually flowing faster than other parts of that river, and we call that the jet stream. All of these need to come together just right, and most often they come together just right in the middle part of the country. That's what we call Tornado Alley. That's where all those weather ingredients come together just right most often. But you know what? These weather ingredients can come together just about in any state. And like I said, every state in the United States has seen tornadoes, but they just most often occur there in the middle part of the country. I like to show this map because this looks like a bunch of red spaghetti, but this actually depicts all the tornado tracks from 1950 to about 2016. And you can see it looks like spaghetti, but each one of these red lines, some of them are little dots because the tornadoes were very short. And some of them, like over here in Georgia, you can see this one line, are very long because the tornado was on the ground for a long time. Now, how do tornadoes form? Excellent question. I will be honest with you. We don't fully understand the full process or how tornadoes form, but in general, this is how they form. What happens is that in the atmosphere, you've got winds at different layers of the atmosphere. I know that we're all used to thinking of just where we live down here, but the atmosphere actually goes up for several miles straight up, and the winds can blow from different directions in the atmosphere like that. And as we do, the winds blow. Sometimes they're blowing actually opposite of each other. So near the ground, they can be blowing from one direction, and higher up, they can be blowing from the opposite direction. And what that does, that creates a turning motion in the atmosphere. If you've ever seen like mom or dad who, when they're making maybe a cookie dough or bread for the bread dough, they're using a rolling pin. And they're rolling it back and forth, back and forth. Well, that rolling pin is that rolling motion that we can get in the atmosphere. So we get a rolling motion, and it's kind of a horizontal rolling motion, but every once in a while, if you get the right kind of thunderstorm, that thunderstorm will turn that horizontal rolling motion, and it'll flip it up on its end. Now it's a vertical rolling motion. And that vertical rolling motion starts to twist. And if it's the right kind of thunderstorm, it will actually tighten that circulation down. And as that circulation gets tighter and tighter, it spins faster and faster. If you've ever seen like an ice skater in the Olympics, as she's skating around, she's doing her routine. Usually at the end of her routine, she will spread out her arms and she'll start to spin around real slowly. But then as she draws her arms in, she'll spin faster and faster and faster and faster. And then she puts out her arms and says, stops, and says, give me a gold medal. Well, what happens is that as she was pulling in her arms, she was tightening her circulation up, and that was making her spin faster and faster and faster. Well, the same thing happens with these certain time of thunderstorms. They tighten that circulation up, and it gets going faster and faster, and eventually it gets so fast that's what drops at the bottom of the thunderstorm, and that's what we get as a tornado. So those are basically how a tornado forms.
Okay, so at this point, it's already 3 minutes to 11 o'clock. I know how time flies.
I know.
And I see lots and lots and lots of great questions, but we don't have time to answer them all. So here's what I'm going to do. If you guys can quit chatting for just a minute, I'm actually going to put my email address up here. I'm afraid to do this because I know I'm going to get lots of questions, but it's okay. You can send those questions to me at the university, and then I will get people to answer them for you.
Yes.
So you can send them to that address that I just put on the screen in the chat room, and I will try to get the questions answered for you by experts in the fields that you're asking about. A lot of the questions had to do with things like natural disasters and so on that may not pertain to weather. I'll make sure I get the right people to talk about it. The other thing I wanted to show you guys real quick, if I can, and let me get it up on the window here. And I'll share that. And you're going to see a tornado that I took the picture of. This occurred in Santa Fe last summer. And this was a picture of a tornado that I took just north of Santa Fe last summer. So it is possible to get tornadoes here. Just thought I'd let you know. And it doesn't happen very often, as Tim and others will tell you. It's very seldom that we see those, except especially in the northeast part of the state, we'll get a few more. But down in the Santa Fe, Albuquerque, Las Cruces areas, very seldom see them. Again, just want to remind everybody that we've got other sessions coming up. So I'm going to stop sharing and share that for you. If you want to join us for any of these, give me a second. Here we go. And we'll bring that up. So we've got tomorrow, and since you brought up tornadoes here, he will answer a lot more questions about tornadoes and hurricanes, and lightning came up here. Tim will answer questions about lightning tomorrow, and that occurs from 1 to 2 p.m. So you can join us again with Tim tomorrow and ask all kinds of other questions. And then we're going to do a live weather balloon launch. That'll happen at 10 a.m. on Saturday as part of the expo, the final get-together for this thing. And then we'll also be doing official Skywarn training. This is where we train spotters for the National Weather Service. And that will happen between 6 and 8 p.m. on Saturday. So those are the things still coming up. And don't forget, we have all these that have been recorded. And we also have these recordings under Science Destination. So lots and lots and lots of things about weather. Many of your questions will be answered there. Let's thank Tim. Thank you, Tim, for joining us and doing this for us. We really appreciate it. And guys, it won't take long if you stick around and you go to a lot of these sessions. It won't take long for you to even begin to get to the point where you can figure out what cloud it is and figure out how tornadoes work and explain it to other people. And then you'll become like me, an amateur weather forecaster. And Tim will tell you the amateur is the key word in that because I'm not a great weather forecaster, but I do pretty well. Okay, folks, I think we're going to wrap it up here. And I'm going to go ahead and let our sponsor know that we're going to end the recording. And thank you very much for